And so this idea of like these people who are making these seemingly impossible decisions, also relying on, just another person, another mentor who's also struggling with like how to do good in the world. And that was a really important moment for me, that like when you see these people, they seem like they're doing the craziest things. They realize like they're just people. They had to grow their, muscles of courage and capability over time, and that if they could do it, you could do it too.
Hi, welcome to Season 2 of my podcast, All About Her. I'm your host, Shreya Anand, and I'm a high schooler interested in STEM. Join me as I speak to various women in STEM to learn all about her experiences and advice for girls like me. Before we get into today's interview, I just wanted to mention that my TED Talk is now out. Link is in the description if you guys want to check it out. I talk all about the main things that I've learned from my interviews so far, and I would really appreciate it if y'all could go like and comment on that video as well. Today, I'll be speaking to a woman who is an adjunct professor and executive director of biopolicy and leadership initiatives at the Department of Bioengineering at Stanford University. She attended both MIT and Queen's University and has worked with everything from stem cell research to now COVID population analysis. So please welcome Dr. Megan Palmer, and let's jump right into Season 2, Episode 1. Thank you so much for joining me today, Dr. Palmer. Would you mind explaining what your current career is and what you specialize in?
Sure. First, thanks for having me today. I'm really glad to be speaking with you. So my name is Megan Palmer. I am currently the Executive Director of Biopolicy and Leadership Initiatives at Stanford University. I am also an adjunct professor in Stanford's Department of Bioengineering, and I'm an affiliate of the Center for International Security and Cooperation that is also at Stanford. And I'm a bioengineer by training, but most of what I do these days I often call engineering biology at social scales, which means I study and work on a lot of the social and policy issues that are coupled to our increasing ability to engineer the living world and engineer biology. And so I have a group at Stanford, but I work with a lot of people in a lot of different organizations who are thinking about, how do we think about, as we're engineering life, how we ensure that that is a world that we want to live in.
Before we get into kind of all the more technical stuff, I wanted to try a new little segment today, which is the kind of favorites section, if you will. So okay. I have 7 quick questions, just one-word responses, or if you want to elaborate, obviously, go ahead. But just to get to know you a little bit better. So first question, what's your favorite food?
Probably ice cream.
Do you have a favorite flavor?
Dark chocolate with some salt on it with a very tiny spoon.
Do you have a favorite color?
I love the color I'm wearing right now, which is sort of a greeny blue or almost a turquoise.
I was going to say
there's some significance behind that, but yeah, greens and blues.
Nice. Mountains or beaches?
Oh, mountains, for sure.
Really?
I grew up in the Rocky Mountains up in Canada. I'm from Calgary, Alberta, and so I grew up hiking in the mountains and lakes over beaches and oceans.
So California hasn't changed your mind about that?
No, California has some good mountains too.
True, very true. Favorite place you've ever traveled to or you want to travel to?
Those are there's so many places I want to travel. What I loved, about working in a lot of global policy issues is the chance to go and experience different communities around the world. I am very fortunate in that I have an ongoing collaboration with researchers in Paris. So I have a lot of excuses to go to Paris often. And that's a wonderful place. And speaking of mountains, I had a wonderful trip to go hang out in some pretty great mountain ranges in New Zealand a few years ago. I really enjoyed that as well, but many more places to explore.
And finally, favorite animal?
This was actually very tough. I recently was working on a piece of art with a friend of mine that involved choosing a bunch of favorite animals amongst all of our group, not only animals, but also favorite plant that are representative. But the one I actually chose was a rabbit. And I actually have a white rabbit in my office. And there's something about Alice in Wonderland and the white rabbit that I really love.
All right, so those are kind of the fun questions. I learned a lot about you just from that, but
I love it.
Let's get into kind of, I guess, more about your career, how you ended up where you are today. Something I like to always ask the women that I interview is, did you ever see yourself in this position when you were younger? Did you have any dream jobs as you were growing up that, you saw yourself doing?
It's an interesting question. I feel like I really didn't have a lot of, clear visions about what I wanted to be when I grew up. I do remember pretty early on, probably in high school, being really excited about science and engineering. And I think I had a kind of stereotypical vision of myself in the future, wearing a lab coat and working in a lab. I thought that was pretty cool. But I also had some, amazing mentors and people in my community that did a lot of public service and a lot of community service and community work. And but I don't think I really had really clear ideas. And I still feel like I'm trying to figure out what I want to do when I grow up. I mean, I'm still kind of in school, you could say, all these years later. I never really left school. And so sometimes I think about, well, what would I do if I left school, if I left the university? But a lot of our visions evolve along the way, but those themes of science and engineering. I also really loved English and writing and then public service. And somehow all of that I've been able to incorporate in some of my career now.
Did you take like an engineering class in high school, and was that when you kind of like figured that you really enjoyed it, or when do you think you just kind of really figured that out?
It was interesting. My father was an engineer. He worked in more the oil and gas industry. He was actually an electrical engineer, but then was working in a lot of places where there were reservoir engineers. But I remember telling my father when I was growing up, I was like, I don't want to be an engineer. It was really boring. But I think I had a really narrow vision of what that entailed. And then I actually started when I was in undergraduate. I chose my undergraduate degree because I liked my biology class and I liked my chemistry class. And I thought, well, I also liked my English class, as I said. And I said, well, I'm biochemistry, those two words fit together. Maybe I'll go to med school. And I took English classes too while I did biochemistry. But in my early on, when I arrived on campus, I went to Queen's University for my undergrad. I consider myself very fortunate to have gone there. I had made amazing professors there. But when I arrived, actually, it has an amazing engineering program And this is also a fun story. There's a tradition at Queen's where all the engineers dye themselves purple and dye their hair crazy colors. And so you arrive on campus and there's these purple people with crazy hair there. And I thought, well, they look like they're having a lot of fun. And in my first year, I met some of the people who were working in these engineering science classes, and I really liked the way they were thinking, and the types of problems they were working on, and so I shifted into engineering. Then actually, when I graduated from engineering, an engineering science, actually it was engineering chemistry degree. There's quite a ceremony in Canada when you get your engineering degree, and then you get a ring, at this little ring right here, and my father actually came to present that ring to me, and I think he thought it was hilarious that I didn't want to be an engineer, and all of a sudden he was getting me my engineering ring. But yeah, bioengineering didn't exist. In Canada at that university at that time. And so it wasn't until later that I was able to combine biology and engineering.
So I guess kind of fast forwarding a little bit, you now find yourself at the intersection of policy and bioengineering. So how did you get there?
Yeah, so that was actually also in my undergraduate degree. It sort of comes back to the same story of being an engineer, but not necessarily wanting to be the same type of engineer, and still being interested in biology. I actually got one of my first summer research positions. It was actually I did a couple summer research experiences, but one of them after my third year was actually back in my hometown in Calgary, Alberta, with in a stem cell bioengineering lab. And this was still really new, but it was chemical engineers that were thinking about stem cells at that time and using reactors to grow up large numbers of stem cells to investigate for therapies. And so I got a summer position working in a research lab. But what was really fascinating is that stem cells are coupled with a lot of ethical and policy considerations. And so I got exposed to this new science, but also the new policy landscape that was evolving there. And then when I was choosing where to go for my PhD eventually, it depended on which country I would go to. The policies around the research that could be done were being decided. And even in that time, I chose to go to the U.S. I was very lucky to go to MIT. And join their bioengineering program, which is just exceptional. It's such an amazing program and community. But at that time, it was the middle of a U.S. Election, and stem cell policies were part of the discussion around those policies. So when I got to MIT, I was very fortunate to be able to be within these conversations, not just around the latest in science and technology, but also the latest around the rules and the behaviors and the norms that we bring, that shape the science we do and then what we do with that science. So that's what started me off early on, is this idea of these, science and policy and society are all coupled together.
So kind of talking a little bit more specifically at, I think a couple of your research papers surround interleukin-7, which is used for immunotherapy. In the context of COVID-19, have you and your lab really discovered anything concerning this, and if you're able to share any of that with me?
Yeah, so actually it's interesting you bring that up, because I did go down to the U.S. I did end up working on stem cells, in part because of the way the policies were shaped, and it didn't make sense to be working on them. And so I worked in immunology, right? And I worked on some questions around how does our immune system maintain this diversity so that when we see new types of biological new threats, that is able to respond. And so it ended up being, and I worked on a lot of approaches on how you could understand how your immune system gets shaped and reshaped even after that. And interleukin-7 was one of these cytokines called cytokine and a signaling factor that was important. And we were just trying to study if and how it was important in shaping that response. I haven't worked in an immunology and like actually at the bench in the lab working on those questions for 10 years now, which is hard to believe. It's been 10 years since I shifted over to more these policy and social issues. But that learning about immunology and how your immune system works was such an important foundation. And for anybody who's thinking about it, like studying the immune system, it is just such amazing. It's really inspiring on its own to be able to study that. So now, when it comes to the COVID response, a lot of my work has actually over the last, especially over the last 7 years, has really focused on biosecurity and some of being concerned about these potential pathogens that might emerge, but especially in studying how we can prevent those types of pathogens from occurring, and especially how we can make sure that they don't develop as a result of some of our research. There's lots of naturally occurring emerging infectious diseases that happen all the time. We have to figure out, research to prepare for them, to respond to them. But there's also always this concern that, if we're learning about viruses and about, threats, using our science, how do we make sure that we don't do science that could cause new threats? So a lot of my work has been actually focused more on now the policy responses, but also in studying and enabling different biotechnology communities in research and in industry, and understanding how do they quickly respond to an emerging threat. So it's really on those like industrial policies, safety and security policies that either can help the research happen or make sure that research is done in a way that's safe and secure. And so I'm still very much working on this, but in a different capacity than some of my friends that now are helping to actually develop the vaccines on the ground.
So I guess kind of on this like same topic of COVID-19 and just analyzing response times and things like that, how do you bridge that gap between science and like politics? Because in what I see at a very basic level is that it's very hard to kind of translate between the two. So do you consider your position as kind of like that bridge between the two of them to kind of bring together both of them in a way?
Yeah, there's so many different bridges, and I think that's one of the things that's really important. There's all these communities that have different interests, different values, different areas of expertise that they're bringing together, and we need lots of people who are spanning those boundaries. So some of my work has looked at politics, but often not politics in the sort of like national politics we think about. Often it's like tiny politics, the politics in organizations, the politics in any relationships, the idea that really anything we do is sort of political in a way because it has to do with our values and interests and the way we bring them about. And so some of my work has looked at, how do we understand the sort of political strategies that people use? And sometimes like people will use arguments to sort of deflect the argument, or they'll use it to deter the argument, or they'll use we also use data and arguments in political ways. So that being said, I don't want to ignore the fact that there are these national politics and trends, and I think that a lot of it is how do you do your best to try and show the evidence and show your justification, and how do you develop trust? And so I've also been trying to study like how do different public health communities establish themselves as trustworthy when they're saying, you should trust this piece of advice, or you should trust this particular vaccine, or you should trust this particular doctor. That's sometimes a really, complex argument that's not just about science, right? It's about science and relationships and institutions and communities. So I try to understand kind of the intersection of that, and as much as possible talk about, how we can analyze and understand that, and how we can really zoom out and say, at the end of the day, what do we all care about? How do we make sure that we're protecting public health? How do we make sure that we're protecting the environment? How do we make sure we aren't just protecting certain people or certain parts of the environment? And that's a lot of fostering that conversation.
Kind of, I guess, bringing it out to this, you've been part of so many different parts of science, I guess, and I guess one could argue that they all work together in a way, but have you noticed any kind of gender disparity or any disparity at all in as you've gone through like your education, as you've come upon your career now? Because, as a girl who's kind of looking at her options in STEM right now, I think of engineering and I'm immediately so intimidated. I don't even know why. So I don't know how to get past that. So if you noticed anything going through it yourself.
Yeah, I think that I've definitely seen lots of experiences that have felt, they are not only, like, sometimes it's gender issues, sometimes it's other types of assumptions and biases and ways of working that people will bring to situations, and they don't often see those, and they can be really affecting. There's many issues around inequality and discrimination that exist with our work, and I'm also very fortunate that I have many inspiring examples of people who both are able to, like, call those things out, and have some courage in calling out when they happen, and also are supportive, right? So many of my environments, like, I've been in environments where I've been often the one of the very few women. I've also been in lots of environments where I'm quite young relative to some of my counterparts. That happens a lot, not just imagine working in national security or international security issues, or in government environments. That happens a lot, and so the opportunity, I think, is to find a supportive community that can also understand, and reflect back what you're doing, and then find those champions, those people, both your peers and your mentors above you, who can, you can be sort of like courageous together. Like, sometimes it's good to pay attention to that, like, a little bit of worry, but also don't give it too much respect. Like, we all are trying to be a little bit courageous every day.
I hope everyone enjoyed today's episode. I loved learning about Megan's journey throughout the sciences, and definitely will be applying her advice to my own life. Don't forget to like, comment, and subscribe down below. Check out Megan's LinkedIn and follow me on Instagram for more updates about the show. And in the meantime, stay safe, stay strong, and stay snazzy. Feliz Cinco de Mayo!